Hello, everybody. It's another webinar from the Cloud Security Alliance UK chapter. My name is Vladimir Jerasek. I'm joined with by Sean Turner from the Cloud Security Alliance and Mike Maxey from SmallStep. Today we'll be talking about maybe fairly, boring but very important topic called SSH connections. The cloud inevitably runs on servers, and every server, most of the servers are typically Linux, where the SSH connections are quite important. Organizations also have the SSH servers on-premise or in third parties. And at least from my experience, the managing of the SSH identities and SSH keys and connections is a nightmare. It's complex, and that's where typically cybersecurity breaches occur. From incorrectly managing SSH keys and connections. So we have Mike Maxey from SmallStep to tell us, the UK audience, and Mike is in California, what we are missing effectively in this space, and if there are some better solutions or better systems that can help, either open source or commercial. So. Mike, over to you. If you share the screen, I will put it on screen, and we'll step away with Sean to give you the floor.
Okay, let's see. Let's share this. Okay, that's good.
Perfect. We see that. Thank you, and over to you, Mike.
Great, appreciate it, and thank you for the opportunity. It's nice to talk to the team. My name is Mike Maxey. I'm based in California. I work for a company called SmallStep. We are an open source company, so we have a pretty robust set of certificate management tools out in open source, and we manage not only SSH certificates but X509 certificates. And we're really built for kind of the DevOps shops of the world. We've really focused on sort of a modern tool stack and a bunch of integrations with, kind of cloud native infrastructure and those sorts of things. But today, here to talk about SSH. And SSH is one of those things that everybody's like, oh, it's going away. SSH is legacy. It's one of those things you don't need until you actually do need it. And it becomes sort of your de facto Unix administration tool. But today I'm going to talk more broadly about SSH certificates. A lot of folks don't realize it, but SSH certificates have been part of OpenSSH for, I think, over 10 years now. And they provide a nice alternative to keys. I'll talk a little bit about some of that. The story today is sort of in 3 acts. Using sort of a classic narrative, we'll set it up with the monster, which is really simple public key authentication and some of the challenges around that. We'll talk about our hero, which today is SSH certificates. And then I want to leave you with some guidance on sort of filling the gap, because certificate authentication is only part of the problem. You also want to do things like access control and remove users and those sorts of things. But we'll talk a little bit about that when we get into the final section. But before I get into that, quick backgrounder on me. So my history has primarily been product management, product marketing, really in the enterprise space. So everything from, file systems, object storage to database, more recently PaaS systems. And then today I'm working at SmallStep, which is, as I mentioned, a certificate management company. I'm based in California. I have 2 kids, Matilda and Michael, and we have a Labrador Retriever named Waffles. And I've been with SmallStep about 2 years, but my history is really in kind of product and technology. So let's jump into it. SSH is kind of a terrible experience for everybody. There's really 3 parties involved. There's the developer or engineer that's actually doing the SSH. There's an operations person, typically behind the scenes, managing keys. And then lastly, there's typically a security person who's trying to drive the right practices, but can be challenging as you start to look at SSH and those sorts of things. But let's talk a little bit about sort of a typical new user experience using SSH keys. So what typically happens is you generate, or you become a new user, you get hired at a company, or you need to SSH to a server. So the first thing you need to do is generate some credentials. And given people do this maybe once per employer, or maybe they did it once in college and they're copying their keys around between employers, it's a little bit of an unnatural exercise. What you find is people end up, searching Stack Overflow, or hopefully you have internal docs that go out and tell you how to generate an SSH key. So you run some Baroque command, create a public and private key, and hopefully share your private key with your ops team. Often that's super manual. You can email it, Jira ticket, Slack, put it in GitHub, something to that effect. And then at that point, you wait. Behind the scenes, there's some poor operator that's running through a Rube Goldberg procedure to, in effect, deploy those keys. And this can vary by infrastructure. It's super ad hoc. Typically, what people are doing is using some sort of automation. So if they're running maybe Ansible or Chef or something to that effect, they can push the public keys into that. But it's still a manual process to tee up those, and then you need to wait for that workflow to run, etc. Once that's done, the admin will send a message back to you, and you can SSH. And as a user, you're now allowed to SSH. Your permanent public key has been put on the server you need to access, and you now have access. But you also have permanent access, which isn't ideal if someone leaves the company, because what happens is you now have to go repeat this entire process again. So as an administrator or an operator, it's a lot of work behind the scenes to turn on and off access, and they're permanent keys. So it's important that they're managed appropriately, removed when people leave, etc. From the user perspective, it's not seamless either. You've probably seen these. These are security warnings that you get when you first SSH to a host. We've all been trained to type yes. It drives security people nuts because you're basically just saying, okay, I blindly trust this thing that I'm connecting to. It's pretty similar to the browser you've seen when you're connecting to an insecure site. But as developers, we all just type yes and continue. What's happening here is called trust on first use, or it's abbreviated as TOFU. And as I mentioned, you're in effect blindly trusting the server that you're connecting to. It sends you a verification, and you put your key into your known host file. What's supposed to happen, which most people don't do, is you're supposed to verify a host fingerprint out of band. And that's a pretty onerous process, but doing it out of band, you can then sort of verify that is the host you're connecting to, and you have two-way. You have the client authing the host and the host authing the client. But as I mentioned, most people don't operate this way. Most people just sort of blindly type yes and use a TOFU warning to keep going. You may have seen one of these as well. If you're rekeying hosts, changing usernames, you're going to get something called a host key verification failure. It's an even more scary message put to your clients, often results in a ticket into your security team. But really just one of the fundamental challenges of using static keys when it comes to environments where you're managing lots and lots of hosts and want to rename hosts, rekey hosts, etc. So that's fundamentally the monster, right? It's this simple public key authorization piece. The challenge is there. It's hard to key. It's a static binding that goes on forever. And it's what we all do today. So when Vladimir was doing our intro on the front end, sort of the pain around SSH keys, this is what we're all doing. So that's the monster part of the story. We had talked about kind of a hero, and we believe certificates are the answer. If you're not familiar with certificates, they're typically known as a scary thing, but fundamentally, a certificate is a data structure that binds a public key to a name. So it's a data structure where you have a key bound to a name, and then you have a central trust point called a certificate authority. And as long as you trust the certificate authority and your host trusts the certificate authority, then by default, you two trust each other. And what that means is you no longer have to distribute all your client public keys to every host. And not that anyone does it, but you don't have to distribute your host keys to the clients. Instead, this can be on the fly through a single trusted resource in the SSH Certificate Authority. Let's see, this has been added about 10 years ago into OpenSSH. Certificate support's been there a long time. It's built into your OpenSSH client as well as SSHD on your host, and is just another authentication message similar to keys. The way it's configured is relatively straightforward. On the host side, you modify your SSHD config. You sort of tell it where the certificate authority is located, and you point at the certificate private key and public key. On the client side, you also, pretty straightforward, you update your known host file, tell it where the certificate authority is, and the SSH or the OpenSSH client will pick that up and start using public key authentication. So it's a really pretty straightforward process. Although you do need a certificate authority. And there are several out there. There's a bunch of open source options. A few listed on this slide. A quick Google search, you could find any of these. There's the Netflix Bless stack, which is built by Netflix, uses AWS Lambdas. There's the Uber PAM, which allows you to authorize sudo. There's HashiCorp Vault, has some secrets in it. And then obviously we're sort of partial to our tools. We have a certificate authority that also mints SSH certificates. It's available in GitHub. If you go to github.com/smallstep, you can see all of our open source projects. Step Certificates is our certificate authority, and the CLI tool is the command line tool you can use to configure your OpenSSH clients. We've built some really nice workflows, some one-line commands that allow you to sort of automate all of this. So if you have lots of SSH users and you're kind of concerned about the user experience, we have sort of worked to make that super simple. And once it's set up, it's a relatively straightforward process to maintain. So let's take a quick look. I'm going to do the thing they tell you to never do, which is a live demo. But to do that, I need to share my whole desktop. So let's. Okay, let's get that out of the way. Let's get this out of the way. Okay, so hopefully you can see my terminal. What I wanted to just show is sort of a standard single sign-on flow that you can do by using SSH certificates. So I'm in my terminal window. I'm going to SSH to an EC2 server that we have set up in advance. And what will happen is, just like any employee, I come in on my first SSH of the morning. I have my coffee. I'm ready to get to work. I type SSH hostname, and I hit enter. And what will happen is the system will detect that my current SSH certificate has expired. So with certificates, you can set a lifetime. And once that expires, it's no longer valid. So the system detected that I don't have a valid certificate. So it's prompted me and put me into my browser window to do a single sign-on flow. In this example, we're using Okta. Behind the scenes, we're doing an OAuth flow. So we can work with pretty much any identity provider out there. Most of them support OIDC. So you can use Google, you can use Azure AD, you can use Keycloak. But in my particular example, you're using Okta. One of the benefits of bringing in your IDP is then you can also enforce kind of corporate standards. So behind this, you can put multi-factor, you can put things like impossible travel, you can do sort of really locked down single sign-on flow for your user and do that at a periodic cadence. So once I log in, you can see my browser says I've been authorized. Over here in my terminal window, I connected to my CA, and I've now logged in as Maxi to that host. So it's really as simple as that. Behind the scenes, really two things happened. The first thing that happened is I configured my client for certificates. And the second thing that happened is I logged in to SSH. So let me unpack both of those for just a moment. The first is configuring my client for SSH. And that's what we do. We don't have a proprietary client. We use the standard OpenSSH client. And what we did behind the scenes is we configured that client for certificate access. In effect, we updated the known hosts file with a pointer to our CA, and we told OpenSSH that that's the preferred method for connecting. Again, we don't replace tools. We just sort of work with your existing OpenSSH config, running standard SSH, which is super helpful if you have SSH buried in bash scripts or using other tools that need OpenSSH, etc. The second piece is we logged you in. And behind that was sort of that OAuth flow. So what happened is we detected you didn't have a valid certificate. We put you through a single sign-on flow. In my example, we use Okta. What was returned to the client is an identity token. And this is a signed assertion from Okta that Maxi at SmallStep is truly Maxi at SmallStep. So that proves my identity as a human. So we take that identity token and then we mint a fresh set of key pairs. So we create a brand new client-side public and private key. And we take the identity token and the new key and we submit it to the certificate authority. And the certificate authority returns an SSH certificate with, by default, a 16-hour lifetime. That lifetime can be changed. We chose 16 hours because we think it's sort of a long work day. It's a pretty long work day. But the general idea is you don't generally want to force people to single sign on every time they SSH. You typically want to do one strong authentication per day. And then much like a browser cookie, that certificate runs for a 16-hour period and you continue to SSH to servers until it expires. And then we run the user through a single sign-on flow again. The example I just showed you, I'm using our hosted version of SSH. This is identical to open source. So everything I just described is available in open source. You can configure your IDP, you can wire up OIDC, and it's all very straightforward. Let me flip back. Share my other screen again. Okay.
So Mike, while you are doing that and you are sharing the screen, I will add Sean because there's some question
sure.
About the sessions. I have one question that may not be apparent to people, so asking it on behalf of everybody. Let's say that the certificate has that 16-hour validity. Maybe we reduce it to, let's say, 15 minutes. Okay.
Sure.
Does it mean that after 15 minutes I'm kicked out of that SSH session?
It does not, right? Okay. So you're using a certificate to authenticate, right? You're not using it to sort of maintain that session, do access control. There are ways to do that. And I actually have some ideas on that a little bit later in the presentation. But fundamentally, that is an access point, and we don't, by default, SSH doesn't sort of terminate when the certificate expires.
Perfect. I've also added Francesco Cipollone, our CSA chair, to I think Sean and Francesco might have some questions. Guys, you are on mute though, I believe. So
yeah.
You kind of piggyback on my question that was more on if a session get compromised and like say if you don't effectively expire the session, how can potentially kick out or terminate the session if a session get compromised, especially on lengthy session?
So it was a little hard to hear, but I think the question is, if you have a compromised session, how do you kill it? Is that a fair summary of the question?
Yeah.
Okay. You know, similar to public keys, there's nothing inherent in certificates that allow you to kill sessions. You know, I don't want to do a product pitch, but in our product, we have some capabilities around access control. I mean, fundamentally, what you need to do is do a kill all on those processes and remove that user's home directory and remove that user's account from the system. And it a little bit depends on how you're managing that. There are, you know, you can do just sort of user add and user del. What we typically recommend is something a little more robust, like building your own name switching service stack to do authentication and user management. So there's a few ways to skin that cat depending on kind of how you manage users on your host. But to answer your question, there's nothing inherent in an SSH certificate that will like terminate access or delete stop a session or kill a session.
And then piggyback on that kind of question is, what in your access pattern will be a recommended access pattern in terms of accessing the access service, or would you recommend and would you see the more traditional bastion host or proxy access? What will be a choking point for effectively expiring all the session or dumping effectively the machine to actually kill completely an access or things like that? What would you be your point on those?
Yeah, I mean, I think to solve that, there's kind of two approaches you see out in the wild. One is the one you described where you have a bastion or maybe a proxy in the middle that, you know, in effect becomes a choke point and allows you to kill that session. So if you're connecting to a bastion host and then from that bastion host to your target system, from that bastion host, you could kill that connection. The other approach is you do it on the individual hosts themselves. And that's an approach that we've taken from our product perspective. We sync users to the host, and we basically, if they're removed from access, you delete their home directory and their user account, and access stops. So there's kind of a couple ways to manage around that. And again, it depends on, you know, do you want a central bastion and to manage your users there? There's pros and cons to both, by the way. And then, you know, or do you want to do it at the host level, which can be difficult if you have thousands of hosts without some form of automation.
Yeah, I guess orchestration and automation is exactly hitting the nail. If the machine are ephemeral, if the machines are just cattle that you spin up, spin down, kill, or Kubernetes service or any kind of ephemeral image, that's not a point, because you kill the image, you spin a new one, it's fresh, no problem. I still find from my perspective, that the bastion host is in general a nice choking point and a nice killing point to authenticate, authorize, and potentially monitor and identify divergence from the norm. So I like the approach of the bastion host because, you know, it's a central choking point with the challenge that a central choking point might come. But I have, in your experience over the years, what is the pattern more utilized, or what is the pros and cons other than the one you mentioned?
I would say the pattern we see a lot is a bastion host. You know, I think the reason why is they don't want to expose every host to, you know, the public internet, and sort of building a gateway through a bastion host is a very common pattern. And, you know, I think what we've seen in our open source users is that gives them a nice central point to kind of manage access. And in your example, sort of if they detect a malicious user, go in and take them out. From our product side, and again, I don't want to talk about our product. We manage it at the host level, and we do that because we do have people that don't want to use a bastion. They want to have sort of all their hosts in one VPC and just kind of not have to hop through that. So we elected to go that direction.
Perfect. Thanks, Mike. Let's continue, and I'm sure we'll have more questions later.
Great. Let's see. So I didn't show this in my demo, but here's kind of the one-liner that you would use to configure your client. This is using the Step CLI tool, but you run step SSH config, you give it the URL of your SSH CA, and the fingerprint is sort of a hash of the CA to sort of, it's a form of authentication. You can think of it as that way. And what that does is it will obtain the root certificate. You need to know the root so that you can trust it, and it configures your OpenSSH, which I talked a little bit about in the demo there. So that's the setup. It's relatively straightforward. Let's talk about, kind of the real world and overcoming, some of these obstacles. We hear, the first one is sort of bot accounts. We hear this pretty often. There's quite a bit of sort of machines out there doing SSH, whether it's, a database process running or something to that effect. And there are, you can't send a bot through a single sign-on flow because there's, no one there to type the password. So there are other authentication methods that we support. One example is for cloud environments, we support instance identity documents. If you're not familiar with these, the cloud providers provide a metadata API that's available that in effect attests that a host is owned by you. So if SmallStep has an account in AWS, the instance identity document or that metadata API would be a form of proof that we own a host. And at SmallStep, we can use that to authenticate a host and quickly bring it in. We also have sort of tools that can build on top of that. For example, for bots, you often want to sort of authenticate them by the service plus the machine. If service foo is running on machine bar, that's approved, and therefore you can issue it a certificate. So really what I showed on the front end of this is about humans, but as you're implementing SSH, you're most likely going to bump into use cases that aren't humans. And there's some more information on that link about other ways to manage that. And then to the question earlier about terminating access, there's a couple approaches you can do here. One is use a really short-lived certificate. Again, it doesn't kill your session, but it does prevent future logins. We've seen folks with sort of highly sensitive servers do 1 or 2 minute certificates to make sure that each login in effect is authenticated. You can also configure the authorized principals command. If you're not familiar with this command, it's a function of SSH that provides sort of a pointer mechanism where rather than looking at my local host for authorized principals, I can point it to maybe a central repository where you could have revoked keys. And this would allow, as the user logs in, it would check that command to see if they have office or not. Or if they have access or not. And then lastly, as I talked about earlier, you can just remove the user account to take them off the server. And then we also hear, well, hey, what about access control, right? The great thing, or one of the good things about simple public keys is it has this sort of built-in access control in that if my Maxi's public key is not on that server, I don't have access. So in effect, you can do access control by only placing keys on servers where the individual is supposed to have access. With a certificate-based system, everybody trusts the certificate authority. So in effect, your user, because they're a trusted user, can access any host. So you do need to solve access control a little bit differently when using certificates versus public keys. One approach is to write a PAM module. PAM's a standard Linux utility for access control. It's what we did in our product for what it's worth. The other is, again, you can use that authorized principal command to, in effect, do access control when the user logs into the system. And then adding and removing users on hosts. So to get access, the user has to be there. This is typically done via some config management. You're probably doing it today, so you could keep doing that. Again, you could use an NSS module. I'm not sure I explained what NSS is. It's the name switching service. It's a Linux kernel utility for user management. If you'd asked me how you manage users when we started this project, it would have been through add user and del user and etcd. But turns out the underlying system underneath that is NSS. So NSS is a module you could write that would sort of work in concert with etcd and allow you to manage users. Or you can use the force command, which is a powerful command that will allow you to sort of manage hosts. There's a bunch of information we have around this in our website, but it's very powerful, but use wisely, because you can end up sort of with fail close scenarios and upset users. And then lastly, we hear PuTTY. PuTTY's still around. If you used it on Windows back in the 90s, it's actually still very popular. Today, PuTTY doesn't support SSH certificates. We have had some conversations with the PuTTY maintainer. They're certainly interested in adding it. They just don't have the bandwidth to do it. But for most of our Windows users, since Windows 10, it ships with OpenSSH that does support certificates. So most of our Windows users tend to use the native, I forget the name of the terminal on Windows, the native Windows terminal on Windows 10. That is fundamentally it. I think just maybe throw this up if people want to get some more information. We have a bunch of materials out there. There's a blog post on our site, very popular. It kind of takes you through the pros and cons of using SSH certificates. We have a full tutorial around our open source, kind of a DIY single sign-on that allows you to sort of set up your own whole environment and do what I demoed. And then we also have a product, but don't really want to talk about that today. With that, would love more questions or feedback, comments.
I like the solution, and I think Sean has a couple of questions. We can check if the audience has other question thrown it in. It's really interested. From an entrepreneur perspective and a little bit, how do you find the open source versus the commercial aspects into play? And why are you choosing this kind of approach and versus the more traditional commercial aspect?
I think for us, it depends. Like I think we see two main uses for open source. One is people just want to build the system. They don't want to pay for it. They have good user and host management through CI/CD or some other system where they have pretty strong control over their hosts. And they just want to use the user authentication piece, right? So that's a pretty common flow. Again, some caveats I covered towards the end of the presentation, they have managed and typically do. The other is a lot of folks are using Kubernetes. Sean and I were talking a little bit about this before we joined the call. There's no SSH to Kubernetes. You kubectl exec. So fewer and fewer people necessarily SSH every day. So we do see environments where they're very Kubernetes heavy and sort of as an emergency backup. And when things go sideways and you actually do need to SSH, they would use a solution like ours. And in those scenarios, it's often not worth the financial investment of a commercial product when it's sort of a break glass emergency type solution. So I would say those are pretty common scenarios for our SSH, our open source.
Thank you, appreciate it. Sean, you have any other question?
Cool, yeah. It might dig slightly more into the product territory, but I guess with this, you're granting quite a lot of privilege to your provisioning infrastructure. So you're saying you're essentially giving your provisioning infrastructure access to a trusted CA. What kind of guardrails are there around that? Is there a policy engine? And obviously I'm familiar with Vault, so that's where this terminology is coming from. But is there sort of a policy engine and kind of some approval process or something for what type of certificates get issued?
Sure.
How much does it do of that piece for you, and how much is required to be offset to you?
Yeah, that's a great question. And I think it's really around like, how are you authenticating hosts into the CA? Is that a fair summary? There's a few ways.
Host and people. I mean, identities.
Sure.
So like you're gonna use this for all your SSH. So you're not just gonna use this for your developer keys, developer certs. It's going to be, you're going to issue your administrator certs from the same kind of infrastructure. And how do you kind of prevent sort of mistakes from causing you massive issues?
Okay. So on the let's talk about it as sort of humans and then hosts. On the human side, when you present your identity token from your IDP, again, that's the signed assertion that I'm Maxi at SmallStep. The CA will look at that and decide, based on sort of a whitelist mechanism, should I issue a certificate or not? So if I show up with a Maxi at SmallStep email, but I'm trying to access the Cloud Security Alliance org, my domain's not going to match. It's not going to issue a certificate. So there's a bit of user authentication post the IDP, but the IDP really is kind of the main anchor of, is this an employee and should they have access or not? On the host side, you can bring hosts in a number of ways. The sort of easy button that most people use is we have, it's a multi-use token. It's actually a JWT that we sign. But that token can be sort of used with your CI/CD system to, when you're spinning up an instance, use this token to submit to SmallStep, and it'll allow that host in. It's a multi-use token, which a lot of people don't like. We can also support single-use tokens. So if you don't like the multi-use aspect of it, we can do single-use. I mentioned instance identity documents. That's another way you can authenticate whether a host should be allowed or not. And there's a whole slew of others that are probably a longer conversation. But as part of our toolkit, we've built this concept is called a provisioner, but it's really an authentication mechanism of should we issue a certificate or not. And it's designed to cover a lot of different use cases. And as a host, you can kind of take advantage of a few of them. Does that answer your question, John?
Yeah, cool. It sounds like there's something in there that it would enable you to solve this with a bit of work in knowing what your kind of company rules are.
Yeah, I mean, there's a lot of flexibility there. I mean, it does come down to your threat model, as sort of all security things do. Like, are you comfortable with this threat model? And the trade-off there is generally developer happiness, because the harder you lock things down, it typically impacts your developers. We think we have a pretty nice balance between the two, but we have seen folks take a more extreme, like, hey, I don't like the multi-use, I want to use single-use tokens, for example.
That's fair enough.
Great.
I don't think there is other question. Let me check. No, I don't think there is any other question. I think we are close to time. Maxi, maybe a last message that you want to give to people that are struggling with access control, or where they can find you, how they can follow you, where they can find more information, and then we close with a couple of announcements of the next step for the CSA, what we have in plan.
Sure. I mean, I think the easiest is just go to smallstep.com. We have great blogs and tutorials, like our product self-service. If you want to try it, we have transparent pricing. You can sign up and do it all self-service. I would, encourage you to take a look at SSH certificates, whether you're using us or somebody else. It does solve a lot of pain. There is a lot of manual pushing and sharing keys that goes on in the world, and short-lived credentials solve a lot of those challenges. So I just encourage people to check out our website at smallstep.com, check out our blog, and if you want to get your hands dirty, there's a couple different ways to do that.
Brilliant. Thank you very much. Vlad?
Thank you, Maxine. And we'll definitely be in touch. And I hope that the UK community is going to take up your advice and secure their SSH connections more. Thanks a lot, and have a great day, Maxine. Thanks.
All right. Thanks, everyone.
And on the announcement perspective, so we have currently in the process, so we're going to publish in the next few days an award, and then we're going to announce in our AGM. This is our traditional conference. We're probably going to aim for the end of September, and we will absolutely publish the traditional website, so it will be our traditional event. As always, our commitment for diversity. So please submit your talks. And if you're a woman in cyber, or if you identify in any other gender, please submit, because we highly encourage that. We don't want a male-only driven. But as always, that's our commitment for the community. But other than that, it was a great talk. If you want to get more talk, get in touch with either myself or Vladimir, or event@cloudsecurityalliance.org.uk. Please visit our website for our latest blog. And thank you, everybody, for joining the talk. And as I said, stay safe and stay cloud safe.